Hi, everybody. I'm going to try not to overteach this one. I probably won't meet my goal, but here goes. This is an introduction to linear functions, and I'm going to give you a real life example. And generally, in applied mathematics, there are four steps. We collect data, we analyze the data, we create a mathematical model, and we make a prediction. So I'm hoping to show you all four of those steps with an actual example. Not some fake real life example, but a real one. So here's my example. It says that I'm going to upload 3 IXL sections per day. I'm going to try. This is my goal. Now, I'm not going to probably be able to upload 3 every single day. What's going to happen is some days I'm going to get 2, and I'm going to try to make up for that by doing 4 another day. Last week, I had a couple of days when I had grading due and I had a bunch of other things going on when I got 0 done. Today, I've already done 5. So what I'm going to do is I'm going to try to average 3 each day. Now, the problem with mathematics is when it's applied to the real world is that real world situations aren't neat and clean and perfect. There's a certain amount of estimation that has to be done. So there's 363 skills in the IXL Algebra 1, and I've uploaded 90 already. So will I be able to complete my goal by January 1st? Well, that's the prediction I want to make. Now, in order to do that, we are going to make an assumption. We're going to assume that for each day that goes by, I'm going to average 3 uploads each day. Now, whether I make that or not, hopefully I'll get pretty close to that goal. And we want to see if I do that, if I'll be able to get to 363. Now, this is a pretty straightforward algebra problem, and we could just simply write an equation and solve it and be done. But I want to analyze it just a little bit more than just that. So let's take a look at what we know. It is about October 20th when you're seeing this. Now, again, we're talking about estimation. This isn't going to be perfect numbers. We could find out exactly how many days there are and make absolutely sure that I uploaded exactly 3 every day. But in real life, that's probably not a very good way to approach the problem. We're going to estimate it. So October 20th until the end of the year, we've got November, we have the rest of October, which is about 10 days. It's actually 11 from the 20th. And then we have November and December, all of November and all of December, which is 30 days each, more or less, and 10 days in October, which gives us a total of 70 days until the end of the year. About. We're estimating. Now, the starting point is the Y-intercept, and I had changed this earlier, and I apologize. I decided to start with 90. I'm going to estimate it at about 90 that I started with. And the rate of change is that a positive 3 uploads every day. So there's our data. And what we want to do with that data is we want to create a mathematical model. And the model that we want to create is what we call a linear function. And this is the standard slope-intercept form of a linear equation. And for our purposes here, the independent variable is the one that we have no control over. Well, most of us don't have a whole lot of control over time. If we want to slow it down or speed it up or go backwards and forwards in time, it doesn't seem to work very well. So time is almost always our independent variable. And in this case, we're talking about days. So I'm going to define my variable as x are going to represent the number of days going by. My dependent variable depends on how many days have gone by, and I'm interested in IXL sections that were uploaded. And here's our equation. So we're going to go ahead and use this function in a generic sense and write in what we know. Well, what we know is y is equal to, the slope we're going to assume is about 3. 3 uploads every 1 day. Now, sometimes slope is written as a fraction. That would be 3 over 1. 3 uploads each day times the number of days plus where we started. Well, I started with 90. And this is the equation that we end up with. This is our mathematical model. Now, the point at which we're the most interested in is when I reach how many? 363, I believe. We want to know, when will I reach about 363 uploads? So what I want you to do is think about what you would use this function for. Another way of writing the same thing is we say that y is a function of x. There's no difference between the two of these. It's just a different way of writing it. And what we're really interested in is how many days will it take us to get to 363 uploads? And remember that that is our y, our dependent variable. So set up your equation, choose the right equation and solve it. And I'm going to solve it in the next one. You do it yourself. And here we go. Let's get in there. Come on, there we are. So our function was, I think writing. There we go. F of x is equal to 3x plus 90. That was our general function. And we wanted to know, when will I reach 363 uploads? And this is the question. How many days will it take? And you're going to have to solve this equation. So solve the equation. Don't wait for me to do it for you, and put in your answer. And I'm going to put some solutions there that you're supposed to choose. And to work this out, we're going to subtract 90 from both sides, of course. And that gives us 3x is equal to 253, isn't it? Sorry, 73. Can't subtract today. Got to be careful. There we go. 273. Then we're going to divide by 3. And x is equal to 91. So based on the model that we created, will I make it? Apparently, it's not going to make it. So it looks like I'm going to have to either increase the number of uploads I do each day and try and get my average up, or I'm going to have to postpone or put it off for almost an entire month, because this is 21 days over my limit. So in January, I don't want to wait until January 21st to finish it. So now I'm going to ask the question, how many per day would I have to do in order to make it in 70 days? So this is asking a very different question. That is asking, what rate of uploads do I have to do in order to make it work? And so we're asking for the slope I need in order for this to happen. And we could set up an equation that looks like that. And what I'd like you to do is I want you to think of the equation that would work for this. And we want to make 363 uploads total. And I only have 70 days. Now, what we're going to test is we want to find out what slope will I need in order to do that. And we know I already have 90. So now we're going to solve for the slope that I'm interested in. This is going to be how fast I'm going to upload my videos, and how many will I have to do each day in order to make it. Well, solve the equation and put your answer in. And I like to pause for a second so I can put it in the Edpuzzle. Anyway, we're going to subtract 90 from both sides. Hopefully you did that. Very similar type of problem. That's 273 is equal to 70m. And we're going to divide by 70 on both sides. And m is very close to 4, isn't it? It's just a little bit less than 4. 70 goes into 273 almost exactly 4 times. It's more like about 3.9. But I'm going to say approximately 4, because I can't upload 3.9 per day. I could try and get an average of 3.9, but 4 will make it. So it looks like I'm going to have to change my goal just a little bit. And this was a real problem that applies in real life and has real life consequences for me anyway. And I'm going to have to increase my rate to 4 per day. Anyway, I hope this makes some sense to you. We'll come back and revisit and look at the graph in the next video. So I'm going to stop it here.